Let's do a few vector problems and get adjusted to how we do this. Here's my basic triangle. So once again, I want to label this. So this is my angle A. This is angle B. And of course, this is my right triangle. So this is my angle C, which is 90 degrees always. And then the side opposite of angle A is side A. The side opposite of angle B is side B. And then the side opposite of angle C is side C, which is my hypotenuse. And so to find the sides, I use my SOHCAHTOA. So once again, the sine of angle A is equal to A over C. The cosine of angle A is equal to B over C. And the tangent of angle A is equal to A over B. Also have A squared plus B squared is equal to C squared. So let's do a problem. The map reads as follows. Walk 500 meters north, 200 meters east, 300 meters south, and 400 meters west. What is your displacement? So let's put some vectors here. So let's say I go 500 meters, and I'm going to use, let me redo that. I'm going to use these squares, and let's say each square is 100 meters. So there's 500 meters north, and then I turn and I go 200 meters to the east, and then I turn and I go 300 meters south, and then I'm going to turn and I'm going to go 400 meters to the west. So what is my displacement? And remember, my displacement is how far from my original position do I end up. So that means I'm going to go from this point where I started to this point here. So I'm going to find this vector. So the question is, this one's 500, this one is 200, this one is 300, and then this one going across is 400. Well, what can I do? I can combine my vectors. So if I combine my 500, my verticals together, so I combine my 500 with my 300, I'm going to get a vector of 200. So that means what's left over here is a 200 vector. Same thing for my horizontals. I've got a 400 vector here. I've got a 200 vector here. They're going opposite directions. So this is a 200. And so what I'm left with is I am left with a 200 this way, and I am left with a 200 this way. So now what I want to do is I want to find what is this displacement here. Well, if this side is 200 and this side is 200, what is my vector going to be? I'm going to use Pythagorean, so I'm going to go 200 square plus 200 square is going to equal C square. So C is going to be equal to, I'm going to go, I've got to move this up so I can hit the buttons. So I'm going to go 200 square plus 200 square, and I'm going to hit enter, and so second square root. That's going to give me a vector of 282.84. So my C is 282.84 at, and that's going to be meters, at what angle? Well, I don't need to do the math. I could, but the two sides are equal, so that means both of these angles are 45 degrees. So it's at 45 degrees. And I'm going to just go ahead and say west of north. So I just defined this angle right here. Let's take this one out, and we define this one. So that's problem number one. Problem number two. You shovel snow after a storm by exerting a force of 30 newtons. So let's say I have a force of 30 newtons at an angle of 60 degrees. So I have an angle of 60 degrees. What are the horizontal and vertical components of the force? If you remember the formulas, to find my horizontal, it's the resultant times the cosine of the angle. And to find the y component, it's the resultant times the sine of the angle. So my x, which is going to be my horizontal, is 30 times the cosine of 60. So that's going to be equal to, let me clear this, so 30 times the cosine of 60. And that gives me 15. So my horizontal component is 15. And that's in newtons, and we'll do forces later, but just right now, just know it's newtons. My y component is going to be 30 times the sine of 60. So if I do 30 times the sine of 60, so 30 times the sine of 60, and that's going to give me 25.98. So this is 20. My y component is 25.98. The way I draw that, if I have, let's say I shovel, that's the wrong angle. So let's go down a little bit more like this. And let's say it's at a 60-degree angle here. Then what did I find? Well, my x component is going to be 15 this way, and my y component is going to be 25.98. Last problem. You fly due east from San Francisco to Washington, D.C., a displacement of 5,600 kilometers. You then fly from Washington to Boston, a displacement of 900 kilometers at an angle of 35 degrees north of east. What is your total displacement? So I'm going to draw that. Once again, I'm going to use my, well, this is too long. So I'm just going to say this is going to be my 5,600. So let's label that. So this is my 5,600 kilometers. And then it says I turn and I go northeast. So I'm going to go this way at 900 kilometers. And so that's 900 kilometers. And it's at a 35-degree angles north of east. So that's this angle right here. So now I've got a horizontal vector and I've got a diagonal vector. Now remember, we can move vectors. So here's what I'm going to do. I'm going to take this and I'm going to copy it and I'm going to move it. So I'm going to move it all down here. So let's move it here. So all I've done is I've taken this here and I've moved it down here. What do I do with the diagonal? I find the x and the y. So I'm going to find my x and I'm going to find my y. So to find my x, it's 900 times the cosine of 35, and that's equal to, so let's clear this, 900 times the cosine of 35, and that is equal to 737.24. So I'm going to put 737.24, and that's kilometers, and that's this right here. So that's 737.24. And then I'm going to find my y vector. So my y, or my vertical, is 900 times the sine of 35. And so that's going to be equal to 900 times the sine of 35. And that's equal to 516.22. So let's put 516.22. And so now that's this vector, 516.22. And so here's what I've done. Now I've got two horizontal vectors. I've got two x's. They're both going this direction, so I'm just going to simply add those together. So 5600 plus 737.24. So I'm going to go 5600 plus 737.24. And so I'm going to have a total horizontal of 6337.24. So let's put that in there. So my total is 6337.24 kilometers. And I've already got a y that's 516, and that's my only y. So here's what I've got, and I'm going to attempt to draw this. So now what I've done is I've made one long side there. Oops. Let me try to get rid of that one little hiccup there. There we go. So I've got one, and then I've got my horizontal, and then I'm going to find my displacement, I'm going to find this long side right here, because now I've taken that one side, this and this, and I've made one triangle. So now all I have to do is my Pythagorean. So 6337.24 squared plus 516.22 squared is equal to, and so let's plug that into the computer or to the calculator. So then we'll clear that. So I'm going to go 6337.24 squared plus 516.22 squared, and that gives me that. So I'm going to square root that. And so that gives me a hypotenuse of 6358.23. So my hypotenuse is 6328.53 kilometers at what angle? So now my angle, I'm going to find this one. So what I'm going to do for my angle is I'm going to do, let's see, let me move some of this over here, or let me just get rid of all of this so I can do my work in here. Alright, I've got all three sides, so I'm just going to do the sine of my angle is equal to 516.22 divided by 6328.5. I've got the wrong number in there somewhere, don't I? Let's see, 6358. That's what it's supposed to be. So let's fix that. This is supposed to be 6358.23. There we go, kilometers. So let's change this. So 6358.23. So in my calculator, let's try that again. Move it over here so I can see my numbers. So what I'm going to do is I'm going to go 516.22 divided by 6358.23. Hit enter, and I'm going to do second sign, second answer, and so my angle is going to be 4.65 degrees. So there's my answer at 4.65 degrees north of east.